All right. Hello and welcome back to the Go Rust channel. Last week we got into doing SQLite with Rusticalite, whatever. We did SQLite and it went awesome. We actually accomplished everything that we wanted to do. We found a potential gotcha in doing SQLite, and I think we're ready to move on to the next thing, and that is to start work on our network scanner. So the purpose of this project is to be able to scan a network. I've often, set up a new device and I'm like, oh, what's the IP address so that I can connect to that? And it's usually a huge headache to actually try to figure that out. And it would be nice to just have a list. It would also be nice to run something, save it to a database so that I can see when something new pops up as well. So that's where a network scanner comes into place. And I am sure there's plenty of stuff out there, but I want to move into the more systems programming. I want to move into more Rust, and I feel like this is a good little project to work out how to deal with finding new IP addresses and new hosts on the on my network. So with that in mind, let's get started. Hopefully you're going to enjoy this stream. I am streaming on 2 different platforms, and so we're going to give that a shot, see how it goes. So with that in mind, let's get started. The first thing that I want to do is let's talk a little bit about networks. Now this is something that I get a bunch of random information. We'll just go with that. And it's not necessarily always the best information. So I'm trying to step back and kind of learn from scratch a little bit and kind of build my knowledge back up from the base. So one thing to note, actually first let's start our new project. So the first thing we want to do is we want to create our new project. So do cargo new NetScanner. I don't know. We'll just call it that because I am terrible at naming. So NetScanner, there we go. We'll do touch touch readme.md. Cool. So let's see. Let's do vim readme.md. Okay, so let's take a second and let's start from the very basics of start from the basics that I want to start with, not the very basics. So when you connect to a host somewhere else, you need to know how to contact them and how to talk to them. And generally that is done through an IP address. For local networks, it's IPv4. And cool, that's like 192.168.210.31. So that is an IP address of a host on your local network, and that's how we're going to find them. However, there is a particular thing that you need to know is that, and this is actually really confusing for a long time. If I see so say if I see this, and then all of a sudden I get a /32, then I'm like, what in the world is that 32? Or I see a 24. I'm like, what is a 20? What is going on? And like these CIDR rules, this is called a CIDR rule. It's to specify the range of IP addresses in a particular area that you need to know. I'm like, what the crap? Like, what is it? And so really what is happening is, let's break down the IP address. The IP address is basically 1, 2, 3, 4, 1, 2, 3, 4. And 1, 2, 3, 4, 1, 2, 3, 4 is basically 32 bits. And each one of these comes out to a number. So if you look at your IP addresses, this is actually max of 255.255.255.255. So we can have a max IP address of that, and it's 0 base, so it's 256 characters. Awesome. Kind of cool, kind of whatever. The next thing is we have this for our IP address, But what is this /32? That means, and this is how I look at it, so there could be better explanations somewhere else, but this is how I look at it. That means that whenever I do 192.168.210.31, that means with that /32, that means that is it. That the 32 bits is max full. Like you can't change it. There is no range because you have used all 32 bits to make that IP address. Now, let's say you did 8. Then that means you start at 192.0.0.0 and you go all the way through. So, whoops, stop helping me. So if you do, whoops. Let's do a couple of more. Do 16 and do 24. That means you're at 192.168.0.0. That means you have all the ranges of 0 to 125 and 0 to 255, 0 to 255 in here. So that means you have a vast amount of combinations available. And then finally, this would be 192.168.210.0. So that means that you have available all the IP ranges from 0 to 255. In reality, you don't have that because you have to have 0 and 255 reserved. So you have 1 to 254 available to do stuff with. For the most part, generally you want to stick above 100 just because. We're just going to go with that right now. So that is kind of a breakdown of IP addresses. So what does that actually mean? So for our local network scanner, since I have a local private personal network in my house and it's all on, a set of couple of routers and IP, routers, switches, wireless, blah, 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 then that means that we want to do this range. So that means that we have 255-ish IP addresses, and we want to be able to scan those. And so that means that we need to be able to loop through all of those, but we don't want to do it like, some weird like number crunching. Let's go ahead and actually use some libraries that are built into Rust to be able to loop through this properly. So I actually already wrote this code because I was experimenting and trying to understand CIDR rules for networks. So I'm going to go through and type out some of the stuff based on my network, and then we will go ahead and output it. So let me kind of delete all of this. Actually, we're going to leave that for now. Let's save it. We can come back later and actually do something with it. So let's come over here. And let's do some imports. Use IP network IPv4 network, and then use standard net IPv4. Adder, use standard stir from stir. All right, so we have our function. So the first thing is we want to set our CIDR rule. And again, the reason I wanted to do that is the CIDR notation, because if I want to go in and specify later what I want it to do, I don't want to do something really funky. I want to do a standardized input that people will understand. So let's do CIDR equals 192.168.42 because mine is based on 42.0/24. So I'm going to look for everything that is basically 0 to there. So then we'll do let network equals IPv4 network from stir, and we're gonna pass it in the CIDR rule. Expect invalid CIDR for format. There we go. So basically what this is saying is that we want to get the CIDR network, and if the CIDR rule, we want to get the network information. If the CIDR format is wrong, then explode and blow up in our face. Actually, just gives us an error message. Okay, so next let's do let start equals, we want to do U32, because that's from network dot network. Then let n equals U32 from network dot broadcast. There we go. So this gives us our start and end. Looking at that error up there, I bet I need to install a package I didn't realize. Oh, that's right. It is a package. We'll get to that here. Actually, let's do that real fast. Cargo add IP network. Cool. There we go. So next we want to do for IP in start end. Then we want to do let IP adder equals IPv for adder from the IP, because that's in our loop right there. And then let's just do a print line and for that IP adder. There we go. And that should work. That should give us a list of all the IP addresses in that CIDR rule. Let's write that. Cargo build. Cool. Cargo run. There we go. We have a lot of them. Means starting at 0 and going all the way to the end. So now we can loop through all of the IP addresses in order to actually do something with them. So let's open that back up. And let's just, for fun, let us do 32. And cargo run. See, it shows just the first one there. And it does not show the first one. It shows the one that we specified in that rule. So let's play with this a little more. Let's do 30. See, so that was one thing that I wanted to mention is when you give it the CIDR rule, you're letting the system know how many bits in that 8 bits are changeable. And so in this case, it was 2 bits in that were 1 or 0, so you had 4 possibilities. So, but generally, every time I see people refer to stuff, like I see 8, 16, I see nothing. I see 0. That's rare, actually. Another thing about it, I see 8, I see 16, and 24, and 32. I actually don't think I see 32 all that often. I don't deal with networks a lot per se, and networking and a bunch of stuff. Again, that's something that I want to get more into, and so that's why I'm going through these lessons and I'm kind of trying to loop through. So let's do one more experiment. We'll do with 16. Let's cargo run, does it, and it'll scroll all the way up and see 254, 254. See, we're just crazy amounts. Like, see how it's looping through, you can kind of see how fast it's scrolling, but this one's dropping slowly, but we're getting all of these, going really, really fast. And eventually we would go to the end. But we're not gonna worry about that. So anyway, so that's using the CIDR rules, that's using some of the built-in networking stuff so that we can get the full breadth of what we need, and we have a common format that everybody is aware of. So there we go. So let's do vim source main rs. So yeah, so we have that. Now it's kind of like, what do we do next? So in dealing with networks, you know, we need to, here, let's go back to our README. In dealing with networks, we need to actually reach out and figure out what is on the internet, what is there. And just locally, we might do a ping. So we do ping 192.168.42.32. So now we're going to ping that IP address and see if we get back. What we're doing is we're actually sending a message, and the ICMP server is actually going to respond. You can actually turn off ICMP and the host can still be there, and it's just not going to send us back a response that we're there. So this is where things start to break down in my head, and that's where I want to do a little bit more learning. There is I think it's ARP, and that's another protocol that gives you information about the server, and you can send an ARP packet, packet/request, and this will return back information about the system. And I think an ARP request will give you back a MAC address and some other metadata about the system, some more of the hardware level stuff. And so this is a specific struct that you send as a TCP/IP connection. Same thing with ping. There's a particular way that you send that on a particular port to do that. So, it's kind of like, what do you do kind of situation. I could use a library called pnet, and that's where you can go. It's a low level library for Rust, and we could basically build our own packets to send. I like the idea of learning that, but I don't think I'm there. I'm going to be honest. Like, I've been doing a lot of reading, like, you know, as an example, like you get so in C++ and C, if you want to send a network request, you have to build up, you have to build up a struct of data. Then you have to get the local IP. Stop helping me. Then you have to bind the local IP to a socket. You also have to create a socket. Then you write to the socket. You also have to fill out, in the struct, you have to fill out the destination for that, and you have to fill out a few other things. And the socket is actually a file descriptor to a socket, and so you're actually passing around the FD to bind to the local IP address, and then you write to the socket/file descriptor, and on and on and on and on. Like, a lot of that stuff, you don't necessarily need to worry about, but it's something that I want to get familiar with and learn how to do from an actual doing perspective. So, kind of a long story short, I don't know that I'm ready to do this. However, I think what we can do is we can use, and there's actually something else. So we could do raw sockets or raw packets. We could build up our own packets. We could use an ARP. We can use a library that I call this kind of a mid-tier thing. It is a library, I think pnet, to do ICMP requests and ARP requests. Or we can do a command line, and we can actually use the Ping app, and I think there's an ARP app as well, to do those requests and get a response back, and then we can parse that information as well. So I think what I want to do is I want to go the command line route, and I want to learn, as part of all of this, I want to go ahead and learn how to package up modules, or basically organize code a little better, because I'd like to work with the library, or sorry, I'd like to work first doing command line, get back the specific information that I need in the format that I want it to the main application for doing ARP requests and Ping requests. Then I want to go back in a later video and I want to rewrite the underlying to maybe use the library to get that information instead of using, instead of using the command line argument. That'll be more universal. Then I want to go back, maybe I'll go this far eventually, and write the raw socket information. That'll be a little more complicated, but I think it'll be just as interesting. So that's where we're going. That's where I want to start today, is to doing the command line stuff, because the first thing I want to do is just get some information on the screen, and then I want to actually worry about trying to kind of organize the code and do the other things with it. There is also one thing that I want to go ahead and I want to mention back up here. One thing that I did not realize is when you call the socket.write function on a socket, you can write, say 1,000 kilobytes of data to that socket. However, it's going to return how much was actually written. So if you only write 520 or 523 kilobytes of data, then guess what? You have a whole bunch of data that's not sent. So you have to manage sending the rest of that data. So you have to keep track of how much data is sent to send the rest. Oh, that was super interesting. I didn't realize that was a thing that happened, at least at that low level in the socket level, because I am used to messing with Python, and it just kind of takes care of everything for you. So with that in mind, let's save this. So this README for the moment is just going to be random bull crap, where I just want to talk and write stuff out at the same time. So let us go into our main. Let's move this out into a function. Man, I don't even know what to call this. Let's just call this IPs for now. We're actually not gonna do much with this other than I just want to keep it. I don't want to lose it. Oops, because for the moment, I want to focus on, that's interesting. Interesting. Okay, anyway, so for the moment, I want to work on how do we use command line command and get the information back in. So we're going to jump to our trusty ChatGPT and be like, I am doing a Rust project where I am wanting to ping a remote server on my own network. That's something that I learned discussing stuff with ChatGPT, you have to be specific sometimes. I want to do it on my own, or else it's going to give you this legal paragraph of you can't do this on other people's network, and blah, 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 blah. And when you kind of be like, I'm doing it on my own network, it does that less. So I am okay. I want to use the command line ping app to ping a remote host to see if it returns. a result. How can I do that in Rust? And of course, you're going to do that. So let's refresh. Let's ask again. And send. To achieve this in Rust, you want to execute the ping command available in your system's command line and then process the data. The subprocess, spawn and manage subprocesses through standard process module. This approach allows you to invoke the external programs. Here's a step-by-step guide. See, add a dependency for the basic task. Spawn the ping process using the standard command. To run the ping command, we'll use the -c count option to send a limited number of packets. Oh, that's actually a really good point, because if I ping in Linux, which is what I'm on, if I do ping google.com, it's just going to go and go and go. So if I do ping c to google.com, okay, very cool, very cool. Good to know. So handle the output, capture the standard output, standard out of the command, which contains the result of ping. So question here, just before I read any further, I'm just curious. If I do ping c to 192.168.32. Because I know there's nothing there. So it's going to time out. But what does it return as a return type? I wonder if there's a timeout, so I could have done this a little faster. I wonder if it's 2 packets transmitted, 100%. Yeah, I'm not seeing like an error anywhere. So I think it just tries and then gives you back the result. It took about a second. Okay. So actually, you know what? There we go. There we go. Now I'm gonna stop jumping in and out. Okay. So let's go back here. And all right, so now, we're gonna do command new ping, okay. args c4, yep, where you said output, expect, failed to execute command. So I guess, yeah, we're doing the expect because it's going to return a result, and because we're doing a thing, and if it comes back as not working, then we want to tell the system, hey, it didn't work. If the status is a success, interesting, check the command was executed successfully. That's interesting. Then get the data from standard out, so a reference of output. I wonder what, this is interesting. Ping successful, and then we're giving the output data. Let error, standard error. So if the command did not execute successfully, you can handle the error here. For instance, printing the standard error. No. So based on our experiment, considering it didn't just give us a -1, usually when a command line command, just errors out, it'll give you like a -1 to say it did not execute successfully. However, I don't think ping does that because it just tells you the packet loss rate. Let's go through this explanation and then let's ask it a couple more questions. All right, command new ping initializes a new process. The .args is specified. Yeah, we get output executes the command as a child process. Okay, so the command.new builds it. The output actually executes it. Okay, as a child process, so it is a fork, waiting for it to finish and collecting its output. So it's blocking. That's fine. This method returns a result, which I actually said, that contains the output. So I am learning something of the success. Expect fail unwraps the result. Okay, I didn't specify that because that's actually a good point. The expect unwraps it. It doesn't unwrap, and then returns back the success, causing the program to panic with the given message if the command couldn't be executed. Okay, makes sense. From UTF-8 lossy, that's interesting. Converts the captured standard out into a string, handling any invalid UTF-8 sequences by replacing them with that. Interesting. Okay. This example provides a basic way to invoke the ping command from Rust and print its output. Depending on your specific requirements, you might need to parse the output more thoroughly or handle errors and timeouts more gracefully. Yeah, that's what I was thinking. So it doesn't seem that the ping command returns a -1 when it can't reach a host. Does that mean we need to parse the output to verify we are not getting a result? Yes, you're correct. The ping command exit status might not always indicate whether the host was reachable or not. It primarily indicates if the command executed successfully without system error. Yeah. Successful execution. Yeah. So yeah, that's what it is. It's true. It's like, and that's what I was saying is ping successfully executed. It just didn't have the results that we were after. So yeah. And that's actually, and I like that. Localization of the output format. Yeah. I don't really care about localization because this is for me. We can do more robust parsing later to get more information. That's totally cool. So let's copy this and let's go ahead and paste this. Move you up here. There we go. Cool. Let's kill that. And then let's just start with 192.168.42. Actually, I have no idea what an IP address is on my network that would have something. I'm gonna pull something try to pull something out of my memory. 1.149. This is where this tool would be useful. All right, let's go and cargo run. That's totally fine. Okay, so now it's actually, I think it's actually, yeah, ping execution failed. Failed. All right. Oh, wait. That is not what I expected. That, okay. Let's do R1 and let's try something. Okay, let's do, I want to return back a vec of IPv4 IPv. Oh man, I don't have my Zalige config on here. Okay, for adder. So okay. Oh. Okay, there we go. Okay. So let mute IPs equals vec IP adder. So then we're gonna do IP IPs dot push dot so this is where it takes like doing IPs dot add. See, I don't have enough reps with a vec. How do I add data to a vec, to a Rust vec? I think it's just push. Yeah, push. Oh, I didn't do a new. Okay. That, again, you got to get your reps. Back new, yeah. Then if we'll do IPs dot push IP adder, then we'll return IPs. What? I don't. A syntax error. Vec new. Oh, maybe I don't need a type. I thought I needed to specify a type. Okay. So let's do let IPs let get IPs, just because I don't have a better name at the moment. IPs equals get IP. Dang it. There we go. And then let's do a function ping host, and we want to do a host address. Is that how you do a function? Is never used. Okay, that's fine. So let's go here. Let's paste. No, I don't want to do it. I want to do it as IP. v4 adder. Okay. For host and IPs. Let's do ping host. Let's write that. But, oh, gotcha. Just out of curiosity, let's do host address dot see, converts the given value to a string. You know what? Let's just do this and see what happens. Yep, expected that. So let's do at the as to string. That, I think that should work. We're doing toString, and then we're basically saying, hey, let's slice it. Oh no. Okay, so we're only going to do one. And now I'm going to try to scan this is going to scan the entire thing. This actually might take a while. Let's do, let's see. Ping help, define time to live. Okay, I think the TTL is probably ping t 5. Wait, I wonder if that's seconds. Let's do this. Let's do 1. Let's do 5. C2 192.168.23.32. Let's see what happens. So if this is 5 seconds, we should be waiting a little bit here. 1000 milliseconds, okay. Timeout. That, okay. Can't believe. My brain today, or tonight, is just, it's been a long day. But I'm getting there. We're making some progress. So apparently that had no effect. I apparently suck at this. This is why I'm learning. Like, this is why I'm doing what I'm doing, is I'm trying to learn. I've never done more with ping than, you know, like, hey, can I reach google.com? So this is where we learn. And apparently I don't understand what timeout and time to live mean with ping. So I want to use ping, but I don't want to wait a full second to get a response back, since it is on the local network. How can I wait for, say, 100 milliseconds for a response and then move on? So W, like, but 0.1, like, okay. Wait, where are they putting it in here? After the C? So it shouldn't matter. Okay, that actually went really fast. What? Okay, now what if I don't do... Yeah. Okay. Okay. Cool. Okay, so yeah, that actually worked really well. I don't understand when I did a point, like, I guess I don't understand what this is. Like, is the problem. I can come back to that though. All right, let's come back over here to add in a W and 0.1 there. So conceivably, we should loop through all of these very, 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 very fast. Now, this is not async. This is synchronous. So it's going to loop through them all and hopefully tell us that something worked. We'll see. And let's do a cargo run. Okay. I mean, we're getting failed. We were kind of expecting that. Definitely for some. I was kind of hoping, man, I should have outputted what IP address we're on so I actually know what we're doing here. But I kind of think nothing is going to come back on some of these because I think executing ping is... Oh, wait. Whoa, something happened on... What? Okay, something happened. Wait, what are we doing right now? Oh, 157. Okay. That was 157 up there. 168.1.1. Ping successful on 157. And then it failed. Okay. I wonder if these are unordered. Okay. What the? Okay. I don't know why. Maybe out of habit I did it. Okay. Oh, we did 16. I wanted to... Probably ran that a lot. Yeah. Okay. Yeah. Oops. Okay. So we know that, man, I really... Okay. Let's see, was termination successful? Signal termination is not considered a success. Success is defined as a 0 exit status. So I guess it was returning back a -1 when it didn't work. So we don't need... Actually, we should probably... Yeah. Okay. Okay, I guess I need to alter my command line here because I thought I had something. Oh, yeah, look at that. I forgot about... Okay. Yeah. Oh, my gosh. I used to have a thing here at the end that would tell you the exit status, and I forgot that it's this little, like, caret thing. Green is good. Red is... Because the last one was unsuccessful, it was a -1. Oh, my gosh. Okay. I was wrong, people, and led us down a weird path. So let's come back here and let us tweak. So we're gonna delete this. Whoa, no, don't delete that. Ping successful. Yeah, that's just giving us the output because why not? Let's do... I don't want to do that yet. We don't really have an error per se. Let's do our host. .to string. I think that should be fine. Yeah, let's not do that. Yep. Yeah, I think we'll get the output from that. I think we're good. Let's run that. Let's cargo run this again. Execution failed. Okay. Yeah, we're getting successes. Some are 42, 38, 30. I don't know what some of those are even. 176, 177? What? This is why I need this tool. Like, I'm using a whole bunch of IP addresses I didn't realize I was using. See, 253, 250, let's see, 242? I don't know what those are. So, yeah, so cool. We have successfully used a CIDR rule to get our IP addresses that we want and returned back. Can we do a bool? I actually don't know the return type. What is the return type for a function to return back true or false? Because I haven't done that before. So let's do it. Sure. Bool. Okay. Yep. All right. So in this case, we're not going to do that. We're not going to do that. We're not going to do that. We're going to return, or we're just going to do true. And we're going to do false. And if we get this far, we're going to, can we do a panic? Something went terribly wrong and you didn't succeed or fail at ping. Return true, return false. What? Any code following? That's fine. Oh, yeah. Well, that's not exactly true either. Like, if output dot status dot fail, is there a failed? I don't know if this is a thing. I need a way to look up documentation easily from Vim. Exit status struct Rust. There we go. Exit status, exit okay. Success, that was termination successful. So what is exit okay? Termination is successful, returns a result. Was termination successful? Signal termination is considered a success. Okay. That is a 0. See code. Yeah, let's see. It's just match code. Yeah. Okay. I don't know. Sometimes Rust syntax can be confusing. I wonder if you can only have it blank like that at the very end. I don't know. Okay. So that should return a bool. If ping host print line host exists. I'm being terrible at this. Let's see, host dot to string. There's totally a better way to do this, but I don't know what it is off the top of my head. We will learn at some point. Let us write this. Let's run. Yeah, there we go. Cool. Look at all those IP addresses that are in use. And I don't know what a bunch of them are. Yeah, I mean, especially, yeah, I have no idea. Now, some of these are probably like light switches and stuff, but I have no clue. But at least now I know that with ICMP, getting that data that I'm getting and learning that there is that stuff on my network. So that is good. I am excited about that. And like, and this actually came together pretty quick. Let's look here. When I'm building software on the top of giants here, like that, I mean, that's truly what's going on. So I was able to loop through all my IP addresses. I'm pinging the host. I'm getting the data back. Yeah, I think that's good. I think that's good for tonight. Next week, let's do an ARP request to these hosts to get back information. However, let's research ARP a bit more. This is for y'all and me as well. I mean, but I want to go over the basics. And would ARP requests work when ICMP does not? So to me, I think this would work because I think ARP is like a network card level thing. I could totally be wrong on that. And so that's just something to figure out. Combine ARP and ping requests to help validate that a host is there. Get the MAC address from the ARP request for an IP. Then we want to write the IP and the MAC address to SQLite. So yeah, I think that is what we want to do next week, so that we can, move on to the next step. I think we're getting there. I think this came together a lot faster than I expected. But again, it's not really doing much. I mean, yeah, we're using some of the base stuff, and I think researching this beforehand really helped with that. Again, we're using a command line command that we know and love to get the information, and we're just being like, hey, did this work or not? And then we're just calling that. So we're not really doing a ton of work, a ton of stuff, but we are getting results that we want. And to a degree, I mean, I think it's already provided value. And then later, feature is to add command line arguments to it. So it's a CLI tool. I think that's it. I think we're good. I think we're good for today. I think we successfully did the things that we want to do. And yeah, I'm happy. I think where we need to pick up and learn some more on is better usage of getting the string slice in there. So, because I feel like there's a better way to do this, and I don't know what that is. Maybe, anyway, we can figure that out. It's probably str, actually. Just out of curiosity, str stringify. This macro will yield an expression of type static stir, which is the stringification of all the tokens passed. Yeah, I think that's it. I think that's the one that I want, that macro. Yeah, just for giggles. Let's do stringify host address. Hey, I'm using you. Am I not? I don't understand why the diagnostics have kicked up. But let's not worry about that right now. We did not mean to do that. Yeah, I don't understand. Like, ping host, host address, IPv4. We're stringifying the host address. I don't understand. That should work. Okay. Yeah, I don't understand that. Let's kill that. All right. All right, we're gonna leave it off there. I tried a little something at the last minute. It did not work out. And yeah, so with that, next week we'll work on the stuff. We'll do ARP requests. We'll try to combine some of that. And depending on how well that goes, we might try to go ahead and add that to our SQLite database. I think this was a successful venture into some more Rust dealing with networking stuff. Again, it went a lot faster than I expected, and I look forward to doing more. And so with that, if you want the video on demand version, the backup version or whatever, check out the YouTube channel at Go Rust, and I will see you next time on next week's stream. Have a good one.